Hello everyone, and welcome to the noise-based crystal interpolation tutorial. Noise-based crystal interpolation is geometry nodes modifier setup that I have created, and now I will show you first how to use it, secondly its parameters, and thirdly some edge cases. Noise-based crystal interpolation is, as its name says, interpolation between input surface and the crystals. Therefore, I have downloaded a polyheaven model, as you can see here. It is a closed surface model. I haven't changed much about it. I have only changed the scale to 10. And I have merged the vertices, since there are some overlapping vertices. So you can see the wireframe is the same as the original object. Noise-based crystal interpolation is a geometry nodes modifier setup. In the Blender file that you can download, you can find it as an asset in Crystal Interpolator library. You can see it here. Therefore, to use it, you can just click on your object, create new geometry nodes, and drag and drop from the asset library into your node area. Connect it to the stream, and we already got a result. Firstly, I will jump to the render mode so we can see how the preview looks like. Okay, I'll return to the material preview so we can explain the nodes in more detail. Currently, when you drag and drop it, you have only one node. And to see its parameters, we have to double click it. Now we are inside of the node itself. What's happening is that we are taking the input surface and we are using it for noise-based crystal interpolation, and we are joining its output with the original surface. Okay, let's look at the parameters now. The first set of parameters, the first 5 parameters more specifically, is connected to the proxy surface. Proxy surface is built upon of the input surface and it is used for crystal extrusion. The first is the flag for non-closed input surfaces. Since we are working with a closed input surface, for now we'll just focus on the first 2 parameters. First is the proxy surface resolution, meaning that if I use a smaller number, I have the finer resolution, for example 0.1, and the crystals will be much more finer. If I use larger value, meaning that it's a coarser resolution, I will also get more larger, coarser crystals. Let's stick to the 0.2 for now. As you can see, the second parameter is non-uniformity. Currently it's 0 and all the crystals are more or less uniform. If I increase the non-uniformity, for example 0.4 or 0.2, I will get some of these crystals which are larger and some of the crystals which are smaller. As you can see, the second 2 parameters for the proxy surface are grayed out, and they are enabled when I checked non-closed input surface. Just a tip, this non-closed input surface can be used for closed surfaces as well, but if you have non-closed surface, only these 2 parameters can be used. Okay, and in this case, we have the options to process our proxy surface in terms to simplify it. For example, if I lower the simplification, I will get much more detailed crystals because the surface is much more than detailed. And if I increase simplification, that I'm actually getting larger crystals because I'm simplifying the surface, I'm merging the surface. I will stick to the 0.2 for now as well, and subdividing the proxy surface only in a case if my original surface is not really subdivided enough. I will not use it for now. I will check out this non-closed surface since we are working with a closed surfaces, and we can stick with these 2 parameters. And before I go further, I will reduce the non-uniformity to 0 again, and I will increase proxy surface resolution so I'll make it a bit more coarser. Okay, but this is all up to you how you prefer it for your model. Okay, then after that we have three parameters which are connected to the noise mask and inversion of the noise mask as a fourth parameter. So the first is the noise mask scale, meaning that if we have, for example, lower scale, we will have larger clusters of crystals. And if we have, for example, larger scale, we will have smaller clusters of crystals, like this. I will stick with the scale, for example, 0.8 for now, and go further. The second is the mask density. The mask density is actually filling or removing the crystals from the noise mask, like this. And the morphing, the third parameter, is keeping the scale and density the same, but just moving them across the surface. So kind of a jittering, but structure-aware jittering, like this. And the final parameter regarding where the crystals appear, connected to the noise mask, is inversion. So if I quickly want to invert what I see, I can use this check. Now, after this, we have three more parameters, which are connected to the geometry, look and feel of the crystals. First is the minimal and then maximal extrusion, and the third is complexifying of the crystals. So if I, for example, lower the minimal and the maximal extrusion, you can see that crystals are quite small. If I increase, of course, the extrusion, then I will get much more larger crystals. I will set them to some values that look fine currently. And the third option is the complexification of the crystals. So by default, it's turned on. So if I unchecked it, I will get something like this. So these are much more kind of simplified, but also interesting crystals. For now, I will keep it turned on. And the final parameters that we have, it's connected to the crystal material. We have a predefined crystal material checked on, and with predefined material, directly in geometry nodes, we can change the color of the crystals. We can change the glass to the metal ratio and the roughness of our crystals. I will, for the sake of this example, also turn on the render mode, so you can get much nicer results. So for example, when I change the color, we can see that we have a lot of different possibilities directly in geometry nodes, which is quite nice. And for the metallic surfaces or more glass surfaces. And finally, roughness. And finally, if you do not want to use predefined crystal material, you can simply uncheck it and put any kind of a custom material that you have created. For now, I will check predefined crystal material. Okay, and now we have gone through all of these parameters which are offered by noise-based crystal interpolation setup. And now I want to show some of these edge cases. Let's say that your input surface or input model is non-closed surface. So here I have a plane, and this plane is infinitely thin. I haven't added any solidify to it. And if you want to apply crystal interpolation to it, as we discussed before, we click on our object, create geometry nodes, and from asset library, we just drag and drop it on our mesh. And then you can see something quite weird happens. This is definitely not what we expected. This is because if we go inside of the crystal interpolation, we have to check non-closed input surface. Currently, our surface is really not closed, it's infinitely thin, and it doesn't work with first two set of parameters for the proxy surface creation. So I will click on non-closed surface, and yeah, we have the desired result as we wanted. Of course, we can then simplify it or make it more complex. So if I simplify it less, then I'll have more complex surface. If I simplify it more, I will have like more larger crystals. And if we want, it's also possible to subdivide it further, but this is now not needed. All the parameters are then working as same as before. So if you want to change the scale, if it's so smaller groups of crystals or maybe larger groups of crystals like this, we can also play around with density to fill it in or close it. We can morph it around the surface, preserving the density and the scale. And of course, we can invert it when needed. We can play around with crystal extrusion, minimal and maximum crystal extrusion, like this. And we can also change the parameters of the predefined material. So for example, the color, as we have seen, and I will shortly jump to the rendered mode. So the color, or for example, the roughness, or metallic ratio. Let's look at another edge case. Let's say you have a model which is a infinitely thin plane, so no solidify, and it's an open surface. And it doesn't have a lot of faces. Let's apply crystal interpolation. I will click the new in geometry nodes and drag and drop my asset. Here, we can see that crystals maybe are not what we expected. Let's see how can this be fixed. It's connected to the proxy surface. So it's about the first parameters. Since we are working with non-closed surface, we have to check this and work with simplify proxy first surface and subdivide proxy surface parameters. We don't need to further simplify because this surface is already quite simplified. What we can do is actually subdivide it. I will subdivide it by 2. Now, what happened is that my surface, proxy surface, is subdivided, and our crystals are then much more nicer because the surface from which they are extruded, it's more complex. It's a heavy operation, so I would suggest you use it with care. And further, we can use everything what we learned as before. So if we want to have smaller clusters, then we will go to the larger scale of the noise. And if we want to, for example, I will go back to the smaller clusters like this. And if we want to change the density, we can also work with this as well. So having more crystals available. I will reduce the density again to the 0.4. And of course, we can morph it around the surface, just changing the parameters as we need. Let's look at another edge case. Here I have a plane, so thin, infinitely thin, non-closed surface, but also it's very detailed. So there is a lot of faces. And if you want to create a crystal interpolation, we create geometry nodes and drag and drop our asset and put it here. It'll take a few more seconds because it's quite detailed. So you can see that crystals are very much maybe too detailed, too small. For this case, we have to go inside and we have to use non-closed input surface since we are working with really non-closed surfaces. And we have to simplify it. So I will simplify it, for example, 0.4 to get crystals which are much larger. Maybe this is too much. I will put a maybe 0.25. So this is the way how can you actually use the input surface and simplify it to create a proxy surface on which the crystals are then created. And then finally we have all these nice possibilities also shown before, so basically everything stays the same as before. Let's look at another edge case. Let's say that you're working with really small objects. So I will just scale my sphere to be really small, like this. And I will of course apply its scale. So it's very small object. If I want to apply noise-based crystal interpolation, I will go to new, and under noise-based, I will just click it here. You can see nothing actually happens. This is because our scale of the object is really too small. You can just enlarge your object, apply the scale, and then work what you need. For example, you want to change a bit of the resolution, so it's a bit larger crystals, maybe some non-uniformity as well, changing a density a bit like this, and morph it if needed. Okay, and change the color. And when you're satisfied, I suggest that you go object and then apply and then visual geometry to mesh. Now we have applied the modifier and we can then scale our object to be small as we want. Apply scale, so it's actually a small object with all the details.